Hello everyone, welcome to your physics classroom. I am Lawal Aditiji, your physics tutor. Welcome back to your classroom. That one to our returning viewers. To our new viewers, this is the first video of ours that you are watching. So welcome to physics classroom. Please do well to subscribe, press your notification bell, press your like button, like and share, and put your comment in the comment box. Thank you so much, and let's continue with the business of today. As we have found that we are in the season of Neco 2025, and we are started analyzing the possible questions, and likewise, then based on the information we are receiving every day. So, in this video, we have another question here to solve concerning Neco. Please do well to watch all our videos on all the subjects that we have released. Just press the notification button, and likewise check our playlist. You will see all the videos that will benefit you for this Neco. And likewise, we have released videos for post-UTME and likewise for the upcoming DCE. Now, here we have a question on the board for Neco 2025 preparation. The first one said that we should state Hooke's law. We should state Hooke's law. You know, when you talk about Hooke's law, this is a concept. Please do well also to watch our video on elasticity. So we have the content on it very rich. So when you hear the word Hooke's law, it's talking about a topic called elasticity. In this topic called elasticity, what you want to bring out there is talking about the extension of the elastic material, the extension of the spring. And then when you extend it, when it is being compressed and when it's being stretched, you know the thing is to return back to the normal. By how far or by how much has it been stretched or compressed? That is the extension. That extension is what this particular law based on. But how can that extension be done? When load is applied on that spring or elastic material, that's where you can see that extension we are talking about. Let me show you in a brief, within a minute, how it works practically. What I'm holding right now is what we call spring balance. What it does is measures the load that is any load that is being applied on it. You will see the way we always, whenever we go to fill our gas, you know, they need to check the capacity or the weight of your cylinder before they start putting gas inside. Likewise, to get the actual one you want to buy. You can see the presence of this load as stretched has been read on this spring balance. Now, telling you that there is a spring inside this spring balance. That's why I call it spring balance. Now, I'm holding spring. This spring that you are looking at now, it has its own natural length. When I mean by natural length, when there is no load on it. Now, if you now apply load on it, what do you see? What can you see from? What can you see from it has been stretched? This is what the Hooke's law is talking about. Now, let me now state the Hooke's law without taking your time. Hooke's law states that provided the elastic limit is not exceeded, that is, you have not gone far, you have not destroyed this particular elastic material, provided the elastic limit is not exceeded. Now, what will now happen? The extension of the spring, that is, as I'm extending it, it will go back to normal. The extension of the spring is directly proportional to the load. That is, if I'm increasing this load, the extension should be increasing. That's what it says. So let me put it down. As we are answering the question, it says solution. Solution. Hooke's law states that. Hooke's law states that. Hooke's law states that. I can say provided. This statement provided can also come last. It depends on you. It can be the beginning, it can be the end. But what matters is that relationship between the extension and the load. Provided the elastic limit is not exceeded. That is, you are still in that movement, you are still in that range. It's not exceeded. You now say the extension of the spring, if you like, you can say extension of the elastic material, because spring is just an example, one out of like thousands of elastic materials we have. The extension of the spring, and we call that one E, is directly proportional. Is directly proportional to what? To the load or force applied. I may not put load, it may be my hand. that I'm applying on it, that's stretching it. That's why I say load or force applied. I will use F to denote that. So the law, as we stated, if I want to show it mathematically, I will say mathematically, F is directly proportional to E. Changing the proportion, mathematics people, F equals to KE. The formula stands where the K is the spring constant. Someone can say force constant, you're still saying the same thing. Elastic constant, you're still saying the same thing. That constant is what we're talking about. That's it. Let's now say you want to find K. You just know, make use of the formula K is equals to F over E. If the situation repeats itself, then we now saying F1 over E1 equals to F2 over E2. So all these explain what we call the Hooke's law. We have answered question 1. Now we have a calculation question to back it up. Now, going to that calculation, I want to do my calculation here out. Alright, now we want to solve this problem. Very simple question. A spring has a length of 0.20 meter when a mass of 0.30 kg hangs on it. Something is fishing here. Let me just, as I'm here in front of you on your screen, I just appear with a spring with load. Definitely, I have hidden something from you. What is that thing I've hidden from you? The original length of this spring. Because I just entered with the spring with load. What about when the spring was without load? Something was free. That's what I told you. That is, in this situation, there was a situation where the spring was a load, but the information about it was not given. So that's why we need to remove it now. They said, yeah, we cannot say given. Let me say given. Given. When held, I'll call that one L1. L1, 0.20 meter. The mass, that is the M1, was 0.30. Please do well to watch we have practical content on Hooke's law. We have full classroom on Hooke's law and elasticity. Please do well to watch our video in your playlist. Alright. Now, we have the L1, M1. We have settled the matter of 0.2, 0.30. Please don't forget that extension is equal to new length minus original length. We are still coming there, but let's interpret the problem before we start applying. Now, it has said again that, and the length again, the new length, that is L2. L2, that is, let's say this load again, that increase the load. L2, when that has been increased, we have 0.75 meter, and our M2 is 1.95 kg. Alright. Now, it has been interpreted. That is, we have used this information. That's how we should find the what? We want to find the force constant. We want to find K. Now, remember I told us that something is missing as information. The original length of this thing we don't know. Let's call that one L0. And you know, to find K, the formula from the Hooke's law said F equals to KE. And you know, E is always new length, that is Li minus L0. Now, let's start now. Look at my hand here. My L1 is 0.30. Then my E1 will be L1 minus L0. For this place, my L2 0.this, that is, I will have E2 equals to L2 minus L0. Everything is still obeying that statement. new length minus original length, new length minus original length, new length minus original length. Now, remember I told us that under this Hooke's law, when we are having the formula, I said when the situation repeats itself, we have F1 over E1 equals to F2 over E2. Now we go F1 over E1 equals to F2 over E2. But before I can move on with my head, the question was given in form of mass. Convert your mass to weight or to force. How can we convert mass to weight? Thank God you have been given acceleration to gravity, which is G, F or W equals to mg. So without any wasting time, directly my F here becomes mg, which is 0.30 times 10, which is 0.3, this is 3 Newton. My F1, 3 Newton. So this one has become F1. Same thing here. And we have F again equals to mg, which is 1.95 times 10 equals to 19.5 Newton as my F2. So without wasting time, I have F1 as 3 over, what's my E1? What will be my E1? This number, that's my E1, that one becomes 0.20 minus L0. Please let your eyes be checking my information, be following my information. 0.20 minus L0. We have supplied information needed here. Now for this one, what's my F2? 19.5 over my E2. Same thing will happen. Since L2 is this, I'll be having 0.75 minus L0. That is, I will have 0.75 minus L0. Now the information that I need, all have been supplied. Cross multiply. Cross multiply. Now let's cross multiply to get the necessary information. If I cross multiply, I have something like this. I'll be having 3 into brackets 0.75 minus L0 equals 19.5 into brackets 0.20 minus L0. Let's open our brackets. Let's open our brackets. Now I have my calculator with me. Let's hold the calculator as well so to have enough speed. 3 times 0.75. I have 2.25 minus 3 L0 equals 19.5 times 0.2. I have 3.9. 3.9 minus 19.5 L0. Collect like terms. So I'm having 2.25 minus 3.9 equals minus, you can see, minus 19.5 L0. This one becomes plus 3 L0. So let's move forward. I have 2.25 minus 3.9. Here I have minus 1.65 equals, same thing. I have minus 19.5 plus 3. I have answer minus 16.5. Why am I using calculator? So that everything we are doing will be under accuracy. Now we have this, divide both sides by the quotient of L0. Now, so in that situation we are having L0 equals minus 1.65 over minus 16.5. Minus cancel minus. You can check very well, this is just a ratio of this value of 0.1. That is 0.1. What is it? Is it in centimeter? Is in meter. So 0. That is our L0 is 0.1 meter. That information that has been kept for us 0.1 meter. For this time around, the same we should find F. No, we cannot find our E. If you like to any of your E, it can be E1, it can be E2, you still get the same thing. But what matters most, I want to find the extension. We want to find our extension, especially if we have E now. So L new length minus L0. So my E1 becomes, what's my L1? My L1 is 0.2. 0.2 minus what's that? Minus 2 or minus 1. So E1 equals 0.1 meter. I have my extension now. I have my extension E1. If I use that of E2, I'll get the own value of E2. But remember, what I'm after is my K. What I'm after is my K. If you want to work on E2, your own will be E equals to L2 minus L0, which will become 0.75 minus same 0.1. You'll be having 0.65 as your own value as E2. So remember, if you are using E2, we work with F2. If you are using E1, you work with F1. Now, because of my time, F equals to KE. Let me raise it up in 2 bits. Let me raise it up. So I have F equals to KE. For F1, when F equals 3, E equals 0.1, definitely F equals to KE. K equals to F over E. So K equals to, what's my F? 3 over 0.1. K equals to 30 Newton per meter. If you also that you are using E2, if you do the same thing, you will get that. Maybe I should say or to be on the safer side for whoever that's using his own any value. And we have F equals to KE again when F is 19.5 Newton and the E is 0.65. So working with it, I have F equals to, that is, I have 19.5 equals to K bracket of 0.65. K equals to 19.5 over 0.65. If I press my calculator again, and we have the same thing. If I press my calculator, we have the same thing, that is 19.5 divided by 0.65. And we have 30 again. Telling you that no matter any one you pick, you get your answer as 30 Newton per meter. Now, so that's how we set to the issue of the first question. That we should find the first constant. Like I told you, any choice, you just pick your own choice. Now, it's not going to say that find the length of the string when it is unloaded, where there was no load on it. If you are following this question very well, you will have known that you have gotten the answer, our original length. That's what they are looking for, and we have gotten our original length as of 0.1. That is the answer. That is the Roman figure 2. That is the length of the spring unloaded is 0.1 meter. And that is how we finish the question on this. Please take your time to watch the video very well and likewise solve the question and solve all the related questions on this topic, Hooke's law and elasticity. I'm very glad seeing you here, and I'll also be glad to see you in the next video. Please do well to press the subscribe button, your like button, press the notification button, share, and put your comments in the comment box. Thanks for being there for us. Bye. See you in the next video.